Last class we have seen the chemical, the preparation of ethers and the physical properties of ethers along with the nature and all these things we have studied. Now today we are going to study about the chemical properties of ether. We are going to study. Before going to the reactions, let me tell you, ethers have got a functional group, that is single bond O single bond, where alkyl group is attached to it. Either the same alkyl group on either side, or we have different alkyl groups. Now you can see the structure itself, it shows that it is inert in nature. Why it is inert? Because these two group are the electron donor group. Alkyl group are the electron donor group. So it increases the electron density of the oxygen atom. Alright? Due to which what you find is that these alkyl groups repel one another. And due to repulsion, it is being unstable in nature. We can say that. Now you may say that if it is unstable, it should be more reactive. See, unstable means if the reactant, when they react and if it is unstable, then it is more reactive. But here what you find is that the group is, what I said, it is inert in nature. Inert. This particular group, it is inert in nature, because what you find is here the alkyl group, the donor, it gives electron to this particular oxygen, which is already electron rich. It is having two lone pairs. It does not want what you can say electron, but we are pumping to it. We are increasing the electron density, due to which the structure becomes, what you can say, that is unstable. We can say that due to the repulsion, the steric hindrance. So hence the functional group itself becomes inert in nature compared to the OH group in alcohol. In alcohol we find the OH group, which is much more polar and much more reactive in nature. You have seen in alcohol chapter that there is a reaction with the H atom, the reaction with the OH group, the reaction due to the alcohol as a whole, and so many other type of reactions we have seen it. Clear? But here the reactions are limited. Again I repeat, due to the inert nature of this functional group. Alright, due to the inert nature of this functional group, it is having very less reactions. So hence, we will see that very limited number of reactions we will be seeing it in case of what you can say ether, and I will tell you the reason also that why it undergoes. First of all, ethers, when it reacts with halogens, ethers, like suppose I will take here C2H5O, C2H5 plus Cl2 in presence of dark. Alright, in presence of dark, what will happen? What will happen is that you will be getting CH3 here, just I am breaking up this one, okay. CH3, then CH2 is there, one H is replaced by Cl, and we get it here. I don't have the place, I am writing it in this way, or I can do one thing, you will get confused otherwise. Let me write a product here. CH3, CHCl, O, then another CH2, then CH3. I am getting it. See, clear? When hydrogen is being replaced by chlorine, where that hydrogen goes, it combines with another chlorine from here to form HCl. Alright? Now, suppose another chlorine it reacts, same in presence of dark, another chlorine. So what you find is that CH3 now CHCl, so one alpha hydrogen atom I have removed here, isn't it? After the functional group, the carbon atom is called alpha carbon, this is your beta carbon. So one alpha hydrogen atom is removed by Cl. Now what will I do? I will remove the another one. So if it is alpha, this carbon is, and beta, so this particular carbon is known as alpha dash. Alright, and this is beta dash, mind it. So in this way, one more hydrogen I have removed here and I have added HCl. I have added Cl. Alright, I have added here Cl. And here what you will be getting? Minus HCl, because here I have taken two chlorine atoms. So one chlorine atom is coming here, another chlorine atom is combining with the hydrogen which is replaced, and it forms HCl. So what you get the compound? You get it here, nothing but that is a monochlorinated ether, and here you get it a dichlorinated ether. Alright, monochlorinated ether. You will say the name of the compound is alpha chloro diethyl ether. Here it is alpha dash, or you will say no, this is alpha dash, as you wish. So alpha dash dichloro diethyl ether. Alright, alpha dash dichloro diethyl ether, you get it. So in presence of dark you get this particular reactions, we can say. Only that is alpha hydrogen atom is being removed. We can see that. Clear? Now, the same reaction, if I do in presence of light, the same reaction, direct light or simply light, I can write it down here. Light means sunlight. Got it? Then what it happens if I do in presence of light? So you know that halogens in presence of light, the reactivity increases. Alright, you've read in the lower classes. H2 plus Cl2 in presence of sunlight, it gives an explosive reactions to form HCl. You've studied. So in presence of light, what you'll find is that all the hydrogen atoms replaced. All the hydrogen atoms. That is, you will be getting, that is C2Cl5O, C2Cl5. Plus, what happens? How many hydrogen is there? 5 plus 5, 10 hydrogen. So it will form what? 10 HCl. So hence, how many chlorine you require here? 10 Cl2. Why? Because 5 plus 5, 10 chlorine. Here 10 chlorine. So it is 20 chlorine I require here. So what is the compound is formed here? Perchlorodiethyl ether. Perchloro. We can say that. It is nothing but more than 2 or 3. We can say it is per. We can say that. Clear? So it is perchlorodiethyl ether. We get it in presence of light. All the hydrogen atom is being replaced by chlorine. Fine. Next is ether. It forms peroxides. C2H5. I'll write it in this way. Why you will come to know. Then C2H5. Here it is. Ether, diethyl ether I have taken. When it reacts in presence of light and air, this oxygen from where I get it? From air. Isn't it? This oxygen I get it from air. So when it reacts in presence of light and air, light means sunlight. Alright, what will happen? This pair of electron will go here. And what is going to happen here? Yeah, I am going to get, that is nothing but C2H5O, C2H5. It gives a pair of electron to this one oxygen atom. Half O2 means what? One oxygen atom, and it forms what? Peroxides. You can see that. It forms a peroxide. So what is this known as? It is called as an ethereal peroxide. Very simple. It gives a pair of electron to this oxygen atom to form, what is that? Peroxides. It forms. It's a coordinate bond, we can see. And what is this known as? Ethereal peroxide. Now let me tell you a little bit about ethereal peroxide. Ethereal peroxide is highly explosive. Alright, it's highly explosive. Ethereal peroxide is. Before using the ether, we need to make sure that it does not contain any peroxide. Before using the ether, you need to make sure that it does not contain any peroxide. How will you make sure? What it is that if you have stored any ether, for that reason what you know is that ether is available just like chloroform. It's available in smaller to smaller bottles like 5 ml, 10 ml, 20 ml bottles. Similarly, ether is also same thing. If you are storing ether, then if you are using that stored ether, as I said, you make sure that it does not contain any peroxide. What you do is that you take that stored ether, let us say 5 ml or 2 ml, you take in a test tube. Alright, listen carefully. You take 2 ml in a test tube. Add freshly prepared ferrous sulfate to it. Freshly prepared ferrous sulfate you add it to it. Then you add KCNS solution, potassium thiocyanate solution. You add it to it. What I said? Ether, the stored one, 2 ml or 5 ml, whatever it is. Add freshly prepared ferrous sulfate and add KCNS, potassium thiocyanate. If it gives you red color, the solution gives you red color. That means it is being contaminated with peroxide. Ether contains peroxide. Now the question is, fine, it contains peroxide. How to remove that? You have to wash this particular ether either with ferrous sulfate or with conc H2SO4. When you wash it with conc H2SO4 or with peroxide, this peroxide is being removed. This one is being removed because concentrated sulfuric acid acts as the dehydrating agent, and ferrous sulfate, what it will do is that it will get oxidized to ferric sulfate, alright, in presence of this particular oxygen, and as a result the peroxide is being removed. In this way, if it is found, how will you know it is containing peroxide, and how will you remove peroxide? I told you. Now next is, after that, ether, it forms oxonium salt. Oxonium salt. So oxonium means it is made up of 2 words, oxygen and yum, means oxygen is having positive charge. I told you earlier also, that if the name of the radical ends in yum, like ammonium, hydronium, chloronium, that means it is having a positive charge. So oxonium means positive charge. Alright, how it is being formed? See here. Suppose I have taken here C2H5O C2H5. I react with conc HCl. What is going to form here? Pair of electron is there. Now, what is going to form here? See here. C2H5O C2H5. One pair of electron goes to this H plus ion. Conc HCl means what? H plus L minus? Is it right? H plus L minus. So one pair of electron goes to this H plus ion. What I said? H plus, one pair of electron. And Cl minus is here. So it forms on what? Oxonium salt. You can see oxonium. Oxygen is having positive charge. Isn't it? Oxygen is losing now. It's having positive charge. So it forms an oxonium salt. This particular one. Same thing, instead of HCl, you can take H2SO4. What you are going to get it? Here H and here HSO4 minus. Because H2SO4 will dissociate to give you H and HSO4 minus. You will be getting an oxonium salt. Got it? Now, the question is, here the oxonium salt, remember it's unstable in nature. It is unstable. Oxonium salt is this particular one. Now, if you dilute it, again you will get back the ether. If you dilute it, you will again get back the ether. Why? Because on dilution, HCl dissolves in water and you get back the ether. Very simple. Clear? In this way. Now, what is the use of this oxonium salt? Basically, oxonium salt is being, this method is used to remove if ether is having, that is, what you can say, alkyl halide in it. If ether is having alkyl halide in it. Suppose I am having ether C2H5O C2H5. Okay. And I am also having C2H5Cl along with it. In ether it is present. I want to remove this particular one. What you do is that you pass it through HCl. You react with HCl. It will form an oxonium salt. This particular one, which one is going to form oxonium salt? Will it form an oxonium salt? Ethyl chloride? No. That's it. In this way, ethyl chloride is separated from ether. So basically, this technique, oxonium salt, is being used to separate ether from any other compound, like ethyl chloride, as I gave you an example. Understood? That is, ether plus ethyl chloride is there. You react with conc HCl. Now, ether is going to react with conc HCl, as you can see it here. But will this one react? No, not at all. Since it is being separated. Alright? Now, next is, it is going to form, what you can say, it will act as a Lewis also base. Alright? It acts as a Lewis base. Here also it acts as a Lewis base. You can see that oxygen is donating a pair of electrons, isn't it? So it acts as a Lewis base. So we'll see an example where ether acts as a Lewis base. In the next one, we'll see it. Thank you very much.